Hello friends, very good morning to all of you. So today we are going to discuss PF54 part 4.2. We are again in the same subparts of PF54 part 4, that is the registration of the redirect URI. In 4.1 we talked about stealing the authorization code through the referrer. And in this session, that is PF54 part 4.2, we are going to discuss stealing the token through an open redirector. So we'll just try to understand. So let's begin. Yeah, in this section we'll talk PF54 part 4.2, that is stealing the token through an open redirector. So the previous section we talked about how the authorization code can be hijacked through referrer, and here we are trying to understand for the token thing. So in this, both are linked with the redirect URI registration only, and the one line solution is that you have the exact matching design to be configured at the authorization server end, so that whatever the redirect URI client is passing, it should be exactly matched at the ping side, the complete address, not the subdirectory validation. If you are doing those things, you are making your system vulnerable, right? So let's talk about this quickly. So to understand this open redirect vulnerability, we just need to understand the fragment part. What is the URI fragment and how the vulnerability can come through the fragment. So the URI fragment, you can say, is also called as hash fragment, is the part of URL that comes after the hash symbol. That means, let's take an example. You have a URL something called https example.com/hash section 1. So here whatever things coming after hash, that is a fragment. Okay, that part of the URL comes after the hash symbol. Okay, and this is like somehow beneficial also for the single page application. Why? Because in this case, because this fragment is not basically sent to the server, it's basically controlled in the browser only. So that means it's easy to navigate to the multiple section. Let's say you have the example.com with something /section 1, hash section 1, hash section 2, like that. So you can navigate to section 1, section 2 like that, instead of just loading the complete page of your app. So that's something advantage of the fragment, but there is a risk also what we can understand in this open redirector vulnerability. Okay, so then in the context of OAuth, I can say the URI fragment can pose a security risk because fragments are not sent to the server, as I told in the HTTP request. This means that the fragment is only accessible on the client side within the browser. Okay, so you can say that when a user basically just tries to authenticate through any OAuth provider, the authentication server redirects the user back to the client application with the authorization code or access token. And this redirection often includes data in the URI fragment. That means once a request sent from the client to the authorization server will just issue a token in the redirect address. Right? That means once the authorization happened, right? I'll show you an example in this next slide. So once the successful authorization happened, the authorization server might redirect, you have something client app.com/callback has access underscore token is equal to something. So access underscore token is nothing but a fragment that is not sent to the server. It is basically controlled in the browser only. That means if the attacker can just in some way, like any phishing technique, can able to just get access to get the access to that fragment, that access token, then it can call the APIs, and you know what is the impact of that, right? So fragment is never sent to the server. It could be intercepted by a malicious script running in the user browser. We don't know, right? Maybe sometimes we miss that. An attacker could potentially tamper with or leak the access token from the fragment to the malicious actors if the application does not properly handle and protect the token. Correct? So that is something this. And then we have the token leakage and all. Now how this open redirector comes here. So you can see. So I'll show you in the example also. So open redirector vulnerability occurs when a web application improperly allows the redirection to arbitrary untrusted URLs. This is a security flaw where the application fails to properly validate the destination URL in a redirect request, leading to potential malicious behavior. So that means the redirect URI validation, what you are doing, it's not up to the mark. Maybe you are losing somewhere in the terms of validation. You haven't done the proper configuration. Maybe you have allowed subdirectory validation, whatever So that's why you are not doing the validation of exact check of the redirect URI, and that is a miss here. So you know what the redirect URI is? The URL basically which the authorization server will send the user after a successful login OAuth clients must register their redirect URI within the authorized server to prevent abuse. So if you are just configuring the exact redirect URI in the authorization server side, then you are just preventing this problem, right? The open redirector vulnerability. However, if you have the misconfigured OAuth implementation, which allow any URL like untrusted or malicious, thus opening the door for the attacks. For example, you can say an authorization server could be vulnerable to open redirection if it does not validate the redirect underscore URI in the OAuth request as a trusted URL. So then attacker can just craft a URL something like as I mentioned in this slide, that something your authclient.com/redirector. Then you have query with the goto equals to something, the target website. Right? And the target website.com is nothing but a malicious website. So in this scenario, once the user logs in, the OAuth provider will then after the user logs in, the OAuth provider would redirect the user to the malicious site, which could potentially steal the token and the session data, right? So let me go to the next slide. I'll show you. So you can see the attacker can craft a URL like this. So the auth provider.com authorize question with the query response type token, client ID, scope, state, and you have the redirect URI this. Your auth.client.com/redirector query goto is equal to https attacker.com. So you have this redirect URI, and this is the address that the attacker is crafted, and by any technique user is clicking on that from the browser. So if a resource owner, the user you say, has already authorized the application using the tofu like trust on first use, or if they can be convinced to authorize the application again, the resource owner user agent is redirected to the passed in redirect URI with the access token appended in the URI fragment. Correct. So in this case, what happened? Once that authorization happened, because user has already a valid session in the browser, so if user just by mistake click this link using some technique, as already user have a valid session, it not ask for the consent from the user, rather than the authorization server issued a token to the callback address, and that is something like this: your authclient.com/redirector go to https attacker.com with the hash access token is equal to something. So after hash, whatever the things is, that is a fragment. Correct. So in this case, at this point, the open redirect in the client application forwards the user agent to the attacker's website, because you are going to the attacker website, right? The address is go to https attacker.com, right? So since URI fragments survive redirects in most browsers, the final landing page will be something like this: the attacker.com hash access token equal to this one. Now it's a trivial for the attacker to steal the access token, right? It's enough to read the delivered location.hash using JavaScript code. So attacker can able to steal this information by just crafting this address. So why this all thing is happening? Because you are not doing a validation of the redirect URI. That is the only miss in this case, and that what we understand in the previous section also. Where there is a hijack of the authorization code through the referral. So that's why it's I think right now we understand the importance of the exact matching and the proper registration of the redirect URI at the authorization server. That is a very important. If you are not doing, again there is a chances of vulnerability. It's not very easy that anyone can just get the access, but there is a chance there. So both these attacks discussed above can be mitigated by the simple practice by registering the most specific redirect URI possible that would correspond to the complete address in our example. The client can avoid having the attacker take over control of its OAuth domain, right? So there is only one solution for this to get to prevent from this attack. That one is that from the hijacking of the authorization code through the referrer, or the getting you can say the authentication token or the access token leakage through this open redirector vulnerability. So to avoid this two vulnerability, the simple solution is I need to do the exact matching of the complete redirect URI at authorization server end. By doing this, I can just avoid these two. Correct? So I hope you understand this part, right? This is a small session, but this is very helpful. Nowadays, as I mentioned that if you are working with some tool like Okta, Pingfiltrate or any other, those tools are already developed in this way to avoid the vulnerability. But at least we need to know, so that if there is a way we can configure, we can stop that. If an application team or someone is saying, hey, please register this address and allow the subdirectory validation, and if your authorization server is having that possibility also, in that case also you can just think and ask and just stop that, because you can explain that to the application team or anyone, right? Hey, I don't want to do this subdirectory validation because there is a risk in that, and they will consider it. Correct. So this is all about this vulnerability. So we'll jump to the next sections. Like I think maybe it's a part 5. So yeah. Thank you. If you have anything, please put in the comment section.